Welcome to Sleep Science History. Tonight, I invite you to drift with me on a journey across every moment that has ever existed, a calm voyage through the true story of the universe. Before you close your eyes, imagine traveling backward through time itself, past the rise of civilizations, past the era of mammoths and ancient forests, past the age of dinosaurs, past the first spark of life in Earth's young oceans, all the way to the moment when the universe first opened its eyes. Nearly 14 billion years of history await you. History written not in ink, but in starlight, fossils, and the quiet rhythm of the cosmos. Every atom in your body, every breath you take, every star shining above you, all began an event so old, so vast, and so beautiful that they can calm even the busiest mind. As you listen, feel yourself settle deeper into rest. Let your breathing slow. Allow the scale of time to soften your thoughts. Here, in this quiet space, the universe unfolds gently, one chapter at a time. This is more than a story. It is the journey of matter, of stars, of life, and ultimately of you. So get comfortable, close your eyes, and allow the next hour to carry you across the ages. Our voyage begins now. Welcome once again to Sleep Science History. Tonight, we begin a peaceful journey across the vast history of the universe, a story almost 14 billion years in the making. As you settle in, allow the scale of time to soften your thoughts and let each moment guide you gently toward rest. Our story begins before stars existed, before planets formed, before even atoms were possible. In the beginning, the universe was smaller than a grain of sand, yet packed with unimaginable energy and heat. Physicists estimate this moment occurred 13.8 billion years ago, a moment we call the Big Bang. Despite the name, it wasn't an explosion in space. It was the rapid expansion of space itself. Everything that would ever exist, all matter, energy, time, and the laws of physics, unfolded from that tiny, dense state. In the very first fraction of a second, the universe expanded faster than light, in a phase scientists call cosmic inflation. During this expansion, tiny quantum ripples stretched across space. Though impossibly small, these ripples became the seeds from which galaxies would grow billions of years later. As inflation slowed, the universe filled with a hot, glowing soup of particles. Protons, neutrons, and electrons formed and dissolved in a constant energetic dance. About 1 second after the Big Bang, temperatures cooled enough for the first stable particles to exist. 3 minutes in, the earliest elements began to form, mostly hydrogen, some helium, and faint traces of lithium. These simple atoms, forged in the universe's first moments, would become the raw material for everything that came after. But the universe was still too hot for these atoms to bond fully with electrons. Light could not travel freely. It scattered constantly, trapped in a fog of energy. For nearly 380,000 years, the universe glowed with this hot plasma. Gradually, as expansion continued, the temperature fell. Electrons settled into stable orbits around nuclei, and for the first time, the universe became transparent to light. That ancient light still exists today. It travels across space as the cosmic microwave background, a faint glow discovered in 1965 by Arno Penzias and Robert Wilson, an echo of the universe's earliest moment of clarity. With the fog cleared, the young universe was dark, silent, and vast. There were no stars yet, no planets, only enormous clouds of hydrogen and helium drifting through expanding space. But slowly, gravity began to work, drawing these clouds together, compressing them, warming them. Where matter gathered densely enough, pressure at the center increased. Temperatures rose. Hydrogen atoms collided with such force that they fused into helium. And with that fusion, something extraordinary happened. The first stars ignited. The universe was no longer dark. Points of light appeared across the sky, each one a torch born from collapsing clouds of gas. These early stars were massive, far larger than modern stars like our sun. They burned fiercely, producing heavier elements in their cores, creating the building blocks for future worlds. As these stars lived and died, they filled the universe with the materials that would eventually form galaxies, planets, and life. And this is where our journey truly begins. As the first stars ignited, the universe changed forever. For the first time, light pierced the cosmic darkness, spreading through space like gentle lanterns drifting across an endless sea. These early stars, known to astronomers as population 3 stars, were enormous compared to stars today. Some were hundreds of times more massive than our sun. Because of their size, they burned their fuel quickly, living brief but brilliant lives. Inside their hot cores, nuclear fusion transformed the simple elements born in the Big Bang into heavier ones. Hydrogen fused into helium, helium into carbon, and carbon into oxygen. These were the first steps in building the chemical richness of the universe. When these giant stars reached the end of their lives, they exploded in spectacular supernovae. These explosions scattered newly formed elements into space, enriching the cosmic environment with ingredients essential for planets, oceans, and eventually life. Over millions of years, new generations of stars formed from this enriched material. These newer stars lived longer and burned more steadily. Around them, gravity pulled together swirling disks of dust and gas, places where planets could form. As stars gathered together, they shaped themselves into vast structures called galaxies. Galaxies are like cosmic cities, each containing billions or even trillions of stars. Some became elegant spirals, others formed around clusters, and some took on irregular shapes influenced by collisions and gravitational interactions. Our own galaxy, the Milky Way, began as a small cloud of stars. Over billions of years, it grew larger by merging with neighboring galaxies. These mergers were not violent in the way we imagine. Stars rarely collide directly because space between them is immense. Instead, galaxies pass through each other gracefully, blending their stars and reshaping their patterns over long stretches of time. Within the Milky Way, dense regions of gas continued collapsing into stellar nurseries, places where new stars were born. These nurseries glowed with soft clouds of dust illuminated by young, hot stars. One of these regions would eventually give rise to our own sun. The universe, now filled with billions of galaxies, continued to expand quietly. Space stretched, creating more room for stars and planets. Light from distant galaxies traveled across unimaginable distances, bringing us a view of the universe as it once was, long before Earth existed. Around 9 billion years after the Big Bang, in a calm and quiet corner of the Milky Way, a cloud of enriched gas began to collapse under its own gravity. At the center of this cloud, pressure increased steadily until nuclear fusion ignited once again. A new star was born, our sun. The sun formed around 4.6 billion years ago, shining gently in its spiral arm of the Milky Way. Around it, Leftover dust and gas flattened into a rotating disk known as the protoplanetary disk. Inside this disk, tiny particles drifted and collided. Some stuck together through electrostatic forces, forming small clumps. Over time, clumps grew into rocks, then into larger bodies called planetesimals. These planetesimals became the seeds of planets, moons, and asteroids. The formation of a planetary system is slow and delicate. Countless collisions occur, some gentle, some violent. Through this dance of matter, the early solar system began to take shape. Mercury, Venus, Earth, Mars, and the giant outer planets slowly emerged from the swirling dust. Earth, in its early form, was hot and molten, but it held the promise of oceans, continents, and life. As the solar system matured, the sun stabilized, shining steadily and providing the warmth needed for future worlds to evolve. In this chapter of cosmic history, the universe became a place of structure, beauty, and complexity. Stars had been born, galaxies had formed, and one quiet star was preparing to host a small blue world that would one day become home to us. This is the story of how the stage was set for Earth. About 4.6 billion years ago, in a quiet corner of the Milky Way, our solar system continued its slow transformation. The sun shone gently at the center while leftover material, dust, rock, and frozen gas orbited around it in a wide, glowing disk. Within this swirling cloud, small particles drifted and collided, sticking together and gradually forming larger bodies. Over millions of years, these growing worlds shaped themselves into planets. Earth began as one such world, forming through countless collisions of planetesimals. At first, it was a molten sphere, glowing with heat left over from its violent creation. Heavy elements like iron and nickel slowly sank toward the center, forming Earth's core, while lighter minerals rose to create the mantle and crust. Even in these early stages, Earth was already becoming layered, organized, and prepared for the long evolution ahead. But the young Earth was not alone for long. According to modern planetary science, a Mars-sized body, nicknamed Theia, collided with Earth early in its history. The impact was immense, releasing enormous amounts of energy. Instead of destroying the planet, the collision reshaped it. Debris from the impact drifted into orbit around Earth and gradually came together to form the Moon. The Moon played a crucial role in Earth's future. Its gravitational pull stabilized Earth's rotation, preventing it from wobbling too wildly on its axis. This stability helped create consistent seasons and long-term climate patterns. The Moon also generated strong tides, stirring the early oceans and helping shape environments where life could eventually develop. As Earth cooled, volcanic eruptions released gases trapped inside the planet. These gases formed the first atmosphere, made mostly of carbon dioxide, nitrogen, water vapor, and traces of other elements. Rain fell for thousands of years, cooling the crust and filling low-lying areas with water. Slowly, the first oceans formed, covering much of the surface with warm, mineral-rich seas. These early oceans were Earth's cradle, places where chemistry and energy met in just the right ways. Scientists proposed several possible origins for life, including hydrothermal vents on the ocean floor. These vents released warm, mineral-rich water, creating natural gradients of heat and chemistry that could support the formation of complex molecules. Another possibility involves shallow tidal pools, where sunlight and wet-dry cycles encouraged chemical reactions. Regardless of the exact location, Most researchers agree that life began sometime between 4.0 and 3.5 billion years ago. The first organisms were simple and microscopic. They had no eyes, no organs, and no complexity. But they were alive. They could copy themselves, harness energy, and adapt to their environment. These tiny cells mark the beginning of biology on Earth. Among the earliest successful life forms were cyanobacteria, small organisms capable of photosynthesis. They floated through the oceans, capturing sunlight and releasing oxygen as a byproduct. Over hundreds of millions of years, their activity gradually transformed Earth's atmosphere. Oxygen accumulated first in the oceans, reacting with iron-rich sediments. Then it rose into the air, slowly creating the breathable atmosphere needed for future life. During this time, Earth remained a very different world from the one we know today. The continents were small and scattered. The sky may have appeared hazy and reddish due to methane and other gases. But life continued to grow and evolve, adapting to the changing planet. Microbial mats covered shorelines, forming layered structures we call stromatolites, some of the oldest fossils on Earth. For billions of years, life remained simple. But with the slow rise of oxygen, new possibilities emerged. Cells gained the ability to use oxygen for energy, unlocking far greater efficiency. This change set the stage for the next great leap in evolution, the rise of complex, multicellular life. And as Earth continued its quiet rotation around the Sun, the story of life moved steadily onward, preparing for an explosion of diversity unlike anything the world had yet seen. For more than 2 billion years, life on Earth remained simple, tiny cells drifting in ancient oceans, multiplying slowly and quietly. But as oxygen gradually increased in the atmosphere and seas, conditions changed. Cells gained access to more efficient energy systems, allowing them to grow larger, develop internal structures, and eventually join together to form more complex organisms. Around 600 million years ago, the first multicellular life appeared. These early creatures, part of what scientists call the Ediacaran biota, lived in peaceful, shallow seas. They had soft bodies and came in many shapes, leaf-like forms resting on the seafloor, disc-shaped creatures that absorbed nutrients from the water, and gentle, frond-like organisms swaying with the currents. There were no teeth, no shells, and no predators yet, just quiet, slow-moving life in dimly lit oceans. Then, approximately 541 million years ago, Earth experienced one of the most dramatic and fascinating events in natural history, the Cambrian explosion. Fossils from this period, studied extensively in places like the Burgess Shale of Canada and Xinjiang in China, reveal an astonishing burst of diversity. Life expanded in complexity with incredible speed, at least on geological timescales. Creatures developed eyes, jaws, hard shells, and segmented bodies. This was the first time many of the major animal groups we know today appeared. Trilobites scuttled across the sea floor with their armored bodies. Early arthropods swam through the water with paddle-like limbs. Primitive worms burrowed into the sediment. Some strange predators, like the formidable Anomalocaris, patrolled the seas with grasping appendages. These oceans, once calm and simple, had become vibrant ecosystems full of movement and interaction. As millions of years passed, life continued to evolve. Fish developed stronger skeletons and more sophisticated fins. Some species grew protective spines, while others became agile swimmers. Coral reefs began forming, creating rich habitats for marine organisms. The oceans turned into bustling environments, filled with color, diversity, and constant activity. Around 470 million years ago, plants made their first journey onto land. These early plants were small and moss-like, forming thin carpets along damp shorelines. Over time, they developed roots, stems, and vascular systems to carry water and nutrients. As plants spread across continents, they transformed Earth's landscapes and atmosphere. Forests of ferns, horsetails, and towering tree-like plants emerged, providing oxygen and creating new environments for animals to explore. Animals followed the plants onto land. The first to venture out were arthropods, early ancestors of insects and spiders. Not long after, some fish adapted to shallow waters, evolving strong fins capable of supporting their weight. These ancient creatures gradually became tetrapods, the first four-legged animals capable of walking on land. By around 360 million years ago, Earth was home to a wide variety of land-dwelling species. Amphibians flourished along rivers and swamps. Insects, with primitive wings, buzzed through dense vegetation. The planet's atmosphere held more oxygen than today, allowing some insects to grow to remarkable sizes. Through the Carboniferous period, vast forests covered the continents, and thick layers of plant matter accumulated in wetlands. Over millions of years, this organic material transformed into the coal deposits we find today. The air was warm and humid, and storms rolled across lush landscapes filled with life. As time passed, early reptiles evolved, becoming more independent from water and capable of thriving in drier environments. This shift marked a turning point in Earth's history, setting the stage for new groups of animals to emerge and dominate the land. Earth's continents continued to move slowly, guided by the forces of plate tectonics. Land masses collided, forming supercontinents like Pangaea, where deserts, forests, and coastlines mixed in vast, interconnected regions. Life adapted to new climates, new pressures, and new opportunities. With each passing era, Earth grew more dynamic, more diverse, and more beautiful. The quiet oceans of the early Earth had transformed into a world filled with ecosystems of extraordinary variety. Soon, a new chapter would begin, one that introduced some of the most iconic creatures ever to walk the planet. The age of dinosaurs was approaching. As the Paleozoic era came to an end, Earth began another dramatic transformation. Around 252 million years ago, the planet experienced the most severe extinction event in its history, often called the Permian extinction. Scientists estimate that more than 90% of marine species and 70% of land species disappeared. The causes were complex. Massive volcanic eruptions in Siberia, climate shifts, and changes in ocean chemistry all played a role. Yet, from this devastation came an opportunity for life to evolve in new and unexpected ways. With many ecological niches suddenly empty, different groups of reptiles began to diversify. One of these groups evolved into the very first dinosaurs. These early dinosaurs were small, agile creatures, nothing like the towering giants we often imagine. But as the climate warmed and ecosystems stabilized, dinosaurs expanded into many forms, gradually becoming the dominant animals on land. The age of dinosaurs, known as the Mesozoic era, is divided into three periods: the Triassic, Jurassic, and Cretaceous. During the Triassic, dinosaurs shared the world with crocodile-like reptiles, early mammals, and many unusual species that have no modern analogs. But by the Jurassic period, dinosaurs had spread across the supercontinent Pangaea, filling forests, plains, and coastal environments. The Jurassic world was warm and lush. Towering conifer forests covered much of the land, and ferns carpeted the ground. Herbivorous dinosaurs such as Diplodocus and Brachiosaurus roamed these forests, using their long necks to feed from tall trees. Predators like Allosaurus hunted across open plains, relying on the sharp senses and powerful limbs. During this time, something remarkable happened. The first birds appeared. Their ancestors were small, feathered dinosaurs that gradually developed wings and the ability to glide or fly. Feathers, originally used for insulation or display, became tools for movement through the air. Fossils like Archaeopteryx provide beautiful glimpses of this transition from dinosaur to bird. As millions of years passed, Pangaea began to break apart. Plate tectonics slowly separated the continents into the familiar shapes we know today. Oceans widened, climates shifted, and new habitats formed. These geographic changes allowed dinosaurs to evolve even further, leading to incredible diversity during the Cretaceous period. Many dinosaurs of the Cretaceous were iconic. Triceratops, with its 3 horns and impressive frill; Tyrannosaurus rex, a powerful predator with keen senses and immense strength; ankylosaurs, armored like living tanks; hadrosaurs, with their elaborate crests and resonating chambers that may have produced deep musical calls. Alongside dinosaurs, flowering plants, called angiosperms, began to appear. Their evolution transformed ecosystems, attracting insects, which in turn helped pollinate these new blossoms. The world became more colorful and diverse, filled with forests of flowering trees, shrubs, and grasses. The seas were equally vibrant. Large marine reptiles like plesiosaurs and mosasaurs swam through ancient oceans. Flying reptiles called pterosaurs soared across coastlines, some with the wingspans larger than small aircraft. The Mesozoic Earth was a planet full of thriving life, each organism shaped by millions of years of adaptation. But around 66 million years ago, Earth faced another catastrophic event. A large asteroid, estimated to be about 10 kilometers wide, struck near what is now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of nuclear bombs. A massive crater, known as the Chicxulub crater, marks the site of the collision. The aftermath was devastating. Debris and dust filled the atmosphere, blocking sunlight for months or even years. Plants withered, temperatures dropped, food chains collapsed. The age of dinosaurs came to an abrupt end, with more than 75% of species disappearing. Yet, as with the extinction before it, this event opened the door for new forms of life to rise. Among the survivors were small mammals that had lived quietly in the shadows of dinosaurs for millions of years. With their competitors gone, these mammals began to evolve rapidly, exploring new roles in ecosystems around the world. The end of the dinosaurs marked the beginning of a new era, one that would eventually shape the world we know today. With the dinosaurs gone, Earth entered a quieter era. Forests regrew, ecosystems recovered, and the planet slowly filled with new life. Small mammals, once overshadowed by giant reptiles, began to explore the world in new ways. Some remained tiny insect eaters. Others climbed trees, glided through forests, or adapted to life in open grasslands. Over millions of years, mammals diversified into many forms: herbivores, carnivores, swimmers, runners, and climbers. As Earth warmed during the Paleogene period, Dense forests stretched across continents. In these environments, early primates evolved. They developed grasping hands, forward-facing eyes, and strong social bonds. These traits helped them navigate branches, communicate, and survive in changing conditions, laying the foundation for our own evolutionary story. Meanwhile, Earth itself was shifting. Continents drifted due to plate tectonics. The collision of India with Asia raised the Himalayas, altering global weather patterns. Antarctica moved over the South Pole, allowing permanent ice sheets to form. Ocean currents changed direction, creating new climate zones. By about 2.6 million years ago, Earth entered a cycle of ice ages, known as the Pleistocene. These cycles were caused by variations in Earth's tilt and orbit, called Milankovitch cycles. During colder phases, massive ice sheets expanded across the northern hemisphere. During warmer periods, ice retreated, opening new landscapes for animals and plants. These changing environments shaped many species, including early humans. Members of the genus Homo, such as Homo habilis and Homo erectus, crafted stone tools, used fire for warmth and cooking, and formed cooperative groups. Their increasing intelligence and social behavior allowed them to adapt to both forests and open plains. Homo erectus became the first human species to leave Africa. Fossils show they spread into Asia and Europe, living through harsh winters and hunting large animals. Their bodies were built for endurance, and their brains were larger than those of earlier ancestors. They traveled long distances, explored new habitats, and survived through collaboration. During this time, Earth supported many Ice Age animals. Woolly mammoths roamed cold grasslands. Saber-toothed cats hunted in groups. Giant ground sloths wandered forests, and herds of bison and elk moved through seasonal landscapes. These animals thrived in a world shaped by cycles of cold and warmth. Around 300,000 years ago, Homo sapiens appeared in Africa. These early humans developed advanced tools, language, and symbolic thinking. They painted on cave walls, crafted ornaments, and told stories. Their ability to communicate complex ideas made them highly adaptable. Gradually, humans began migrating from Africa into the Middle East, Europe, and Asia. They encountered other human species, such as Neanderthals and Denisovans, and genetic evidence shows that interbreeding occurred. Early humans learned to survive in deserts, forests, mountains, and icy tundra. To endure cold climates, they created clothing from animal hides and built shelters from wood, stone, and bones. They cooked food, shaped spears, and learned to store resources. Every discovery gave them an advantage and allowed populations to grow. By the end of the last major ice age, around 11,700 years ago, Earth warmed significantly. Glaciers melted, sea levels rose, and fertile lands appeared. Humans gradually shifted from nomadic hunting and gathering to cultivating crops and raising animals. This change marked the beginning of agriculture and permanent settlements. Villages formed, then towns, and eventually cities. Humans began shaping the landscape, building societies, and recording knowledge. A species that had once lived quietly in ancient forests had now become the creator of tools, art, culture, and history. Humanity's long journey from simple primates to complex civilizations was underway. As the last ice age ended and Earth warmed, new landscapes opened across the continents. Grasslands expanded, rivers flowed steadily, and fertile soil accumulated in valleys. Humanity, After hundreds of thousands of years, as nomadic hunter-gatherers began to notice patterns in the natural world. Certain plants grew in predictable places. Certain animals migrated seasonally, and the climate became stable enough for humans to experiment with a new idea, one that would reshape history. Around 10,000 years ago, in regions such as the Fertile Crescent of the Middle East, humans began cultivating plants. They collected seeds from wild wheat and barley, cleared small patches of land, and tended crops across the seasons. This gradual shift, known as the agricultural revolution, did not happen overnight. It took centuries of observation, trial, and adaptation. But once it began, it changed human life forever. With reliable food supplies, people no longer needed to travel constantly in search of resources. Small villages formed along rivers and fertile plains. Families built simple homes from mud, stone, and wood. They stored grains in pottery jars and learned to grind flour for bread. They domesticated animals such as sheep, goats, and cattle, which provided milk, wool, meat, and labor. As villages grew, so did cooperation and specialization. Some people became skilled tool makers, fashioning blades, axes, and sickles from stone. Others crafted pottery, wove textiles, or built irrigation canals to guide water to their fields. Communities began trading goods with neighboring groups, exchanging pottery for tools, grains for obsidian, and woven cloth for animal skins. Around 6,000 years ago, some villages expanded into the world's first cities. One of the earliest known regions of urban development was Sumer in southern Mesopotamia. Here, in the land between the Tigris and Euphrates rivers, people built large settlements with temples, marketplaces, and administrative centers. They invented cuneiform, one of the earliest systems of writing, pressing wedge-shaped symbols into clay tablets to record harvests, trade, and stories. Writing allowed knowledge to travel across generations. Myths, laws, and calculations could be preserved, studied, and improved. This marked a turning point in human history. Ideas could now outlive the people who created them. Other civilizations flourished as well. Along the Nile River, ancient Egyptians built a society deeply connected to the rhythms of annual floods. These floods enriched the soil, making farming reliable. Egyptians developed hieroglyphic writing, constructed monumental temples, and built some of the most iconic structures on Earth, the pyramids. Their knowledge of astronomy, mathematics, and engineering influenced later cultures across the Mediterranean. Further east, the Indus Valley Civilization emerged around the same time. Cities like Harappa and Mohenjo-Daro featured sophisticated urban planning, with grid-like streets, drainage systems, and standardized brick construction. Archaeologists have discovered seals with symbols that may represent early writing, along with carefully designed granaries and public baths. In China, early agricultural societies formed along the Yellow and Yangtze rivers, cultivating millet and rice. Over time, these communities developed bronze tools, pottery techniques, and complex social structures that laid the foundation for future dynasties. Across these early civilizations, humans invented tools, calendars, musical instruments, and early forms of mathematics. They observed the stars, tracked the seasons, and created stories to explain natural events. Trade routes connected distant regions, allowing ideas and goods to travel across great distances. As populations grew, societies became more organized. Leaders emerged to coordinate irrigation, manage resources, and resolve conflicts. Religious beliefs developed, shaping rituals and ceremonies that strengthened community identity. The world was no longer a collection of isolated groups. It had become a network of growing cultures, each contributing to the expanding story of humanity. These early civilizations represent the dawn of recorded history. They built the foundations of agriculture, architecture, writing, science, and governance. Their innovations would influence every era that followed. Humanity had moved from wandering the world to building it, and the next chapters would lead to kingdoms, philosophies, and technologies that shaped the modern age. As the last ice age ended and Earth warmed, new landscapes appeared across continents, forests expanded, rivers flowed steadily, and fertile soil gathered in valleys. For hundreds of thousands of years, humans had lived as nomadic hunter-gatherers, following herds and seasonal plants. But around 10,000 years ago, a quiet transformation began. People started to notice patterns in nature. Certain plants thrived when tended, and certain animals could be guided and cared for. This period marked the beginning of agriculture. In regions like the Fertile Crescent, people collected seeds from wild wheat and barley, planted them, and returned months later to harvest. Domesticated sheep, goats, and cattle provided food, hides, and labor. Farming required patience but offered stability. With reliable food, people no longer needed to move constantly. Small villages formed near rivers and fertile land. Homes were built from mud, stone, and wood. Families stored grain in clay pots, crafted tools, and learned new skills. Pottery making, weaving, and simple irrigation systems became common. Over generations, knowledge grew, and communities became more connected. Trade began between nearby settlements, spreading ideas and goods. By around 4000 to 3000 BCE, some villages grew into the world's first cities. One of the earliest was Sumer in Mesopotamia. Here, people built temples, workshops, and marketplaces. To record harvests, trades, and stories, they invented cuneiform, one of the earliest writing systems. These wedge-shaped symbols pressed into clay tablets allowed ideas to be preserved and shared, marking the start of written history. Further south, along the Nile River, ancient Egyptian civilization flourished. The Nile's annual floods enriched the fields, making farming reliable. Egyptians developed mathematics, medicine, and a form of writing known as hieroglyphics. They built monumental temples and pyramids, carefully aligning them with stars and cardinal directions. Their knowledge of astronomy and engineering influenced many later cultures. In South Asia, the Indus Valley civilization created cities such as Harappa and Mohenjo-Daro. These cities were remarkable for their planning, straight streets, drainage systems, and standardized bricks. Archaeologists have found seals with early symbols, pottery, tools, and evidence of long-distance trade with Mesopotamia. In China, early societies along the Yellow and Yangtze rivers cultivated millet and rice. Over time, they developed bronze tools, artistic pottery, and systems of writing. Their observations of nature, weather, and the heavens formed the beginnings of Chinese philosophy and science. Across these regions, humans experimented with new technologies. Bronze tools improved agriculture and craftsmanship. Boats and wheeled carts increased mobility. Calendars helped farmers track seasons. Music, art, and early religious practices enriched daily life. Trade routes expanded, moving goods such as obsidian, copper, textiles, and spices across mountains and deserts. These exchanges connected distant cultures and spread knowledge widely. As populations grew, Societies became more organized. Leaders coordinated resources, laws were established, and shared beliefs united communities. Building projects, temples, granaries, city walls required cooperation, planning, and social structure. Civilizations began shaping their landscapes, altering rivers, clearing forests, and constructing roads. By this stage, humanity had transitioned from small, scattered bands to complex, settled societies with shared identities. These early civilizations laid the foundations for writing, science, architecture, and governance. Their discoveries would influence every chapter of history that followed. Humanity was no longer only surviving. People were building, creating, recording, and imagining futures far beyond the lives of their ancestors. A new era of culture, innovation, and connection had begun. As our long journey through the universe and the story of life comes to a gentle close, allow your mind to settle into the quiet that follows. You have traveled across billions of years tonight, from the birth of stars to the rise of early humans, from drifting cosmic dust to the world you know today. And now, here you are, resting in this moment, wrapped in the soft rhythm of your breath and the calm of a universe that has been unfolding since time began. Take a slow breath in and a gentle breath out. Let the weight of the day melt away. You are part of something vast and ancient, something that stretches far beyond limits of sight or imagination. The atoms in your body were forged in stars, and every breath connects you to the history of the cosmos. Even in the stillness of night, you're held by the quiet beauty of a universe that grew and changed for billions of years so that life could exist, so that you could be here listening to this story. As you continue sinking into rest, I hope you feel a sense of peace, a sense of belonging, and a reminder that the world is full of wonder even in its smallest moments. If you enjoyed this journey through time, I warmly invite you to subscribe, leave a like, and share a comment. Your support helps this channel, Sleep Science History, continue bringing calm, science-based sleep stories to people all around the world. Every subscription strengthens this peaceful little corner of the internet and allows more stories, more discoveries, and more soothing nights to come. If you'd like to hear more stories like this, about the universe, ancient civilizations, science, or the mysteries of our world, your feedback truly helps guide what comes next. Feel free to tell me what topics you'd love to explore on future nights of learning and rest. For now, let yourself drift deeper. Feel your body growing heavier, your thoughts becoming softer, your breath moving slowly and effortlessly. You have listened, learned, and traveled far tonight. There is nothing more you need to do, nothing you need to solve, nothing you need to think about. Only rest. Let the quiet surround you. Let sleep come naturally, gently, in its own time. Thank you for spending your evening here with Sleep Science History. It has been a privilege to guide you through the long, beautiful past of our universe. Sleep deeply, dream peacefully, and may tomorrow greet you with clarity, warmth, and calm. Good night and sweet dreams. As our long journey through the universe and the story of life comes to a gentle close, allow your mind to settle into the quiet that follows. You have traveled across billions of years tonight, from the birth of stars to the rise of early humans, from drifting cosmic dust to the world you know today. And now, here you are, resting in this moment, wrapped in the soft rhythm of your breath and the calm of a universe that has been unfolding since time began. Take a slow breath in and a gentle breath out. Let the weight of the day melt away. You are part of something vast and ancient, something that stretches far beyond limits of sight or imagination. The atoms in your body were forged in stars, and every breath connects you to the history of the cosmos. Even in the stillness of night, you're held by the quiet beauty of a universe that grew and changed for billions of years so that life could exist, so that you could be here listening to this story. As you continue sinking into rest, I hope you feel a sense of peace, a sense of belonging, and a reminder that the world is full of wonder even in its smallest moments. If you enjoyed this journey through time, I warmly invite you to subscribe, leave a like, and share a comment. Your support helps this channel, Sleep Science History, continue bringing calm, science-based sleep stories to people all around the world. Every subscription strengthens this peaceful little corner of the internet and allows more stories, more discoveries, and more soothing nights to come. If you'd like to hear more stories like this, about the universe, ancient civilizations, science, or the mysteries of our world, your feedback truly helps guide what comes next. Feel free to tell me what topics you'd love to explore on future nights of learning and rest. For now, let yourself drift deeper. Feel your body growing heavier, your thoughts becoming softer, your breath moving slowly and effortlessly. You have listened, learned, and traveled far tonight. There is nothing more you need to do, nothing you need to solve, nothing you need to think about. Only rest. Let the quiet surround you. Let sleep come naturally, gently, in its own time. Thank you for spending your evening here with Sleep Science History. It has been a privilege to guide you through the long, beautiful past of our universe. Sleep deeply, dream peacefully, and may tomorrow greet you with clarity, warmth, and calm. Good night and sweet dreams.